All right, in this video, we're going to be talking about prime numbers, prime factorization, and then the title of the video, or I might title it something else, greatest common factor and greatest common factor of monomials. So to start off, we're going to talk about prime numbers. So prime numbers, by definition, are only divisible by 1 and itself. So if we look at the list of prime numbers here, we have 3, we have 7, we have 11, we have 13, we have 17. Okay, so notice how 3 is only divisible by 1 and 3. 1 times 3 are the only two numbers that give me 3. As with 7, only 1 times 7 gives me 7. So 1 in itself. Same thing with 11, 13, 17, and so on. So ones that are not prime numbers, so we have examples here. I have 4, 6, 8, 9, 10. Well, 4 is divisible by 2, and 2 is not 1 or 4. 6 is divisible by 2 and 3. 8 is divisible by 4 and 2, 9 by 3, 10 by 2 and 5. So knowing the difference between prime numbers and not prime numbers. So basically they can't be divided by anything other than 1 in itself. Now prime factorization, every number can be factored into a product of prime numbers. So each number has a unique prime factorization. So no two numbers will have the same prime factorization. So basically all it is it's a bunch of prime numbers that are being multiplied together to get you a, well, bigger number. And we're going to use factor trees to do this. And you'll kind of see why they are named factor trees. So what you're going to do is, and if we look at the first one here, we have 39. You're going to think of two numbers that multiply together to give me 39. Okay, so you might say 3 and 13. Okay, so we'll go ahead and do that. So split it up like this. We have 3, and then we have 13. Now, these right here, 3 and 13, if you can break those down even more, go ahead and do it. But notice how 3 and 13 are both prime. So the prime factorization of 39 is just 3 times 13. So we just multiply those numbers together. Let's take a look at 100. So there are many ways you can break up 100. You can go 250 or 25 and 4 or 5 and 20. Let's do that one, 5 and 20. Okay, so we have 5 and 20. So notice how 5 is prime, so I can't break that one up anymore. I'm going to circle it for now. And 20 is not prime. I can actually break that down even more. So with that, make our two little lines. And what are two numbers that multiply to give me 20? Well, you can say 2 and 10 or 4 and 5. Let's go with 4 and 5. Okay, so now we got 4 and 5. 5 is prime, so let's circle it. 4 is not because I can multiply 2 times 2 to get that. Okay, so is 2 prime? Technically 2 is prime, so you might think that all even numbers are, and if it's not prime, it's composite, but 2 is actually still prime, so the only even number that is prime. So I have 2 times 2 times 5 times 5. So I'm going to write it like this for now. But what I actually want you guys to do is 2 times 2, that's just saying, well, 2 to the second power, an easier way to write it, and 5 to the second power. So those exponents tell you how many of each number are being multiplied. All right, 64, let's break that up. I can use 2 and 32. Okay, 2 is prime, so I'm going to circle it. I can break up 32 even more, so 2 and 16. 2 is prime. 16 I can break down even more, so I have 2 and 8. Circle that. 8, divide by 2 again. And 4 I can divide by 2 as well. So I have 1, 2, 3, 4, 5, 6 2's. So 2 to the 6th power is my prime factorization. Okay, so just a couple more of these. 32, I can break that up into 8 and 4. There's one example. I can actually split up 8 into 4 and 2. 2 is prime. I can split up this 4 into 2 times 2, so the 2's are both prime. And 4, again, I can split up into 2 times 2. So how many total 2's do we have? We have 5. So 2 to the 5th is the prime factorization. So you could do these problems differently. You should get the same answer, though. So at the beginning, you could have said instead of 8 and 4 here, you could have said 2 and 16, however you want to think about it. 120. So how about we do 6 and 20? 6 times 20 will give me 120. I can break up 6 into 3 and 2, which are both prime. I can break up 20 into 5 and 4. So 5 is prime. 4 is not, so I can break 4 up even more. So 2 times 2, and those are both prime. So how many 2's do I have? I have 1, 2, 3, so 2 to the third power, times, okay, we're done with the 2's, 3, okay, done with the 3, and then times 5. And that is my prime factorization. And you might notice how I go from the lowest prime number to the highest prime number. It's okay if you don't do that, but kind of organizes your mind a little bit about what prime numbers are inside that prime factorization.